Now it's time to carve the flat braces. You can see I already got started. This is the upper face brace. And this brace is the largest brace on the soundboard. The thickest, the tallest, and it's the first brace to begin to counteract the weakness that was created when the sound hole was cut out of the top of the guitar. That big sound hole that's cut out of that top reduced the stiffness of the top considerably. And this brace is the first, along with the sound hole braces, to try to bring that stiffness back to this area. It also, if you think about it, the way the guitar is built, the head block or heel block, the part that the neck connects to, there's a big block of mahogany or hardwood of some kind that the neck connects to, and it's glued down to the face of the soundboard. And the tension of the strings pulling on the headstock tends to want to create a bunch of torque and twist and tilt that head block toward the tail of the guitar. And this brace is also designed to help counteract those forces. Now you see me, I switched back to my chisel. I started with that little hand plane or finger plane or whatever you want to call it, but I like the chisel. And now I'm working on the soundboard, the sound hole braces. One of the theories, one of the things that affect the stiffness of a brace is grain direction. The grain direction is quartered, it's running up and down, so it's stiffer that way than it is side to side. But also the height of the brace itself is what gives the brace stiffness. The thickness or width of the brace is not really as important. So the idea is to remove material in certain places without weakening that stiffness. And so one of the ways that is done is by removing material on the ends of braces but leaving the center high. Also, you'll see here in a minute, you see how I've got that chisel turned sideways? I'm cutting material off the sides of the brace and giving it kind of a triangular shape. And what that does is it also removes weight, but it doesn't affect the stiffness because you still have height. So it's a balancing act. What I'm trying to do is, and keep in mind, first of all, that I'm following a plan, but not completely. The shape of the braces, things like that, I took off the plan that you saw at the introductory video at the beginning of this series. But the width and height of the braces I took from the Compiano book. And I'm not really following either one of those plans to the letter. What I'm doing is kind of sort of, I used them as a baseline, and now what I'm doing is sort of kind of trying to feel my way. And the reason is that if I just follow the bracing pattern and the bracing plan to the letter and don't deviate, I'll never learn anything. I'll just be following a plan, and every guitar I'll do the same way, and there won't be any kind of learning taking place. So what I'm doing right now, I've been tapping the top and the back plate Uh, you haven't seen that, but I've been doing it and listening to the sound, and I know nothing about what those sounds mean, but I'm trying to learn. And so as I take braces off of, or take wood off of these braces, I'll also begin to tap. You won't see that because I don't need to make an hour-long video, but I'm just trying to build a light, responsive guitar. I'm trying to kind of feel it, listen to it, and look at it, and kind of figure out, you know, hey, is this light enough? Is this too light? Is it too heavy? And it's just basically best guess. Now, I have done 2 different tops before this. I built a top that I replaced for a friend of mine, and I built an acoustic electric kind of crossover that had an acoustic top. So I've done this before, but it's not like I've done it enough to actually know anything about what I'm doing. But this is how you learn, or it's how I learn. And over time, you know, I'll see what it does to the tone of the instrument and all of that once I get the instrument together. And then, you know, I'll see over time how the instrument holds up, whether or not it changes over time, that kind of thing. Again, kind of thinning the brace without losing any height. Trying to remove as much weight as I can in places where I think it can be done. Now these braces are called the finger braces. And they're probably, it's my guess anyway, that they control the vibrations closest to the sound hole, along with the X braces. And I'm going to feather these. In other words, I'm going to cut these with the chisel till they're all the way, the ends of them are all the way flush with the back of the soundboard. I think these braces probably, my guess would be, is they have a bit to do with the volume of the instrument, how loud it is. But I could be completely wrong. But I would think their proximity to that sound hole is going to make an impact on that. Same way with the sound hole braces. I think they probably would not only reinforce the structure, but they would make a difference. How you shape them, that kind of deal, would make a difference on the volume the instrument produces, along with the back and how stiff it is and things like that. See, I switched to a smaller chisel so I don't chew the soundboard up with that wide chisel, the corners of that wide chisel. I got a chisel that's basically the same width as the brace now to feather it the rest of the way down to the soundboard. And you could shape these braces once the X brace is on here, just like I shaped those sound hole braces that butt up against that upper face brace. But it's easier to do it now when the instrument, the top is flat, there's no arch in it. So you can clamp it down and do whatever you need to do before you put the X braces and the tone bars in, which are arched, which will impart a dome or an arch to the top. And it'd be probably more difficult to clamp it down that way. And then I'll sand the instrument, the braces, and smooth everything out. And then we'll be back with the arch braces. Thank you, bless you. Appreciate you coming along. I'll talk to you later.